So we have seen that a single phase induction motor, it does not have a starting torque, but once it moves, it starts rotating, then it can produce its own induced torque. Okay, so the question is now how to start. So the starting of single phase induction motors. So the starting of 3-phase induction motors was different. The objective there was to reduce the starting current. In 3-phase induction motors, starting methods were used to reduce the starting currents, whereas in single phase induction motor it is used to give the starting torque, because the starting torque is 0. So the very first method that is available is the split phase induction motor. So what happens here? You are going to have 2 windings. Let us say this is the rotor. You are going to have a main winding like this and an auxiliary winding like this. Okay, this is given to the power supply. This is the main winding and this is the auxiliary winding. So these will be spaced 90 degrees apart from each other. This main winding and auxiliary winding, they will be 90 degrees separated with respect to space. Okay, so that means if you have the stator like this, then the main winding is going to be like this. This is the main winding. The auxiliary winding is going to be like this. This is main and this is auxiliary. Okay, so there will be a 90 degrees phase difference between them. Now how to get the time difference, 90 degrees time difference? If both are connected to the same supply, then how do we get 90 degrees is, see, this is going to have a resistance, let us say Rm, and inductance Xm. Every winding will have resistance as well as inductance, right? And the auxiliary winding, it will have resistance Ra and inductance Xa. So what we do is, the auxiliary winding, we ensure that the motor is designed in such a way that the R by X ratio, this is high. When R by X ratio is high, then what will happen to the current? The current will lag only slightly behind the voltage. So that means if you have voltage here and the current flowing through this is the main winding current and this is the auxiliary winding current. Now when R by X ratio is high, this means that the angle by which this current will be lagging this voltage, it will be very less. Okay. What about the main winding? This will have a higher inductance as compared to the auxiliary winding. So this will lag the voltage by a greater angle. So that means if this is the voltage, then IA is going to be somewhere like this and IM is going to be somewhere like this. So now what is the angle between them? This is not exactly 90 degrees, but still it will be a pretty large angle, so that a near to 90 degrees phase angle is obtained. Even if this is not 90 degrees, the auxiliary winding is still ahead in time with respect to the main winding magnetic field. So what will this do? It will help in getting a non-zero starting torque, because they will not cancel each other out. You can write down the net magnetic field due to the auxiliary current as well as the main winding will be a rotating vector. Therefore, induced torque will be produced during starting. Okay. Now after the motor is running at its normal speed, then this auxiliary winding can be removed using a centrifugal switch. Now one point to note here is how to increase the R by X ratio. You can simply increase the resistance. Increasing resistance, there are various ways of increasing resistance, right? One of the common ways that is available is to use a smaller cross section of wire. So the area will reduce, so the resistance will increase. The torque speed characteristics, they can be drawn like this. This is the torque axis, this is the speed axis. Now it is going to, normally what will be the characteristic if there was no auxiliary winding? Then this would be the characteristic. The starting torque is 0. But now what is going to happen? There is going to be a torque like this. Okay. Now once the auxiliary winding is removed, then it will follow the main winding characteristics. So you can write, this is the characteristic when both the windings are present. At starting, we have the main winding plus the auxiliary winding, and this is only the main winding. Another kind of technique used for starting is the capacitor start motor. So here what we do, the auxiliary winding will now have a capacitance also. So that means if this is the rotor, then you're going to have the main winding here, and the auxiliary winding is going to have a capacitor. This again, it can be removed with a centrifugal switch after the motor has come to its normal operating point or the normal operating speed. Now what is the purpose of this capacitor? See, this is the main field winding, main field current, and this is the auxiliary field. So here IA is flowing. Now when there is a capacitor here, it will further increase the phase of this auxiliary winding, so that the phase difference between the auxiliary current and the main current, it is further closer to 90 degrees. Okay. The capacitor in series with auxiliary winding will increase the phase difference between the main winding current, that is IM, and the auxiliary winding current, that is IA, to nearly 90 degrees. And when you have near to 90 degrees, you have seen from the cross field theory that it is possible to get an induced torque. Okay. Therefore, induced torque can be produced due to the 90 degrees or near 90 degrees phase difference between the main winding magnetic flux and auxiliary winding magnetic flux. Okay. So what will be the torque slip characteristics here? This will work better than the split phase motor. Okay. It will have higher starting torque simply because the angle is much more nearer to 90 degrees as compared to a split phase motor. Compared to split phase single phase induction motor. So if this is the torque due to main field winding only, you are going to get a high starting torque which is going to again follow this characteristic once it is removed. Okay. So you can write down, this is the main field plus auxiliary with capacitor, and this is main winding only. Okay. So while it is starting, the torque will be high. It will continue like this. Once the centrifugal switch is removed, then this characteristic will be followed. Another technique that we have is, we can leave the capacitor without removing it even during normal operation. So there are two variations of this. What is that? First one is the capacitor start and run motor, and another is capacitor start, capacitor run. So there is a slight difference, very minute difference. The working is the same only. So what happens in a capacitor start and run is that you will have a capacitor permanently. So that means there will be a main field winding and there is going to be an auxiliary winding with a suitable capacitor, and this is going to be the rotor. So when even under normal condition, when this capacitor is present, what will it do? It will give a rotating magnetic field at a specific load. Okay. The purpose of this is simply that we don't need to operate a switch. Okay, you can simply switch it on from the supply and it will keep running. And because there is a capacitor, there will be a starting torque. Okay. Now what about capacitor start and capacitor run? So this is the main winding and this is the auxiliary winding. Here also you are going to have main and auxiliary winding as it is. You are going to have two capacitances. Okay. So one capacitance will be in the circuit. It will not be removed even after it comes to normal operating position, but there will be an additional starting capacitor. Okay. Because here what happens is the capacitor value that you take, it is a smaller capacitance. Okay. So when you use a smaller capacitor, the normal operation will be smooth, much more smoother. Okay. Smaller capacitor is used so that smooth operation is obtained under normal operating speed. Okay. So that means that the starting torque will be, it will not be 0, it will start, but it will be very less. So the disadvantage is that it has a low starting torque. What is the advantage? No need to operate switch once the normal speed is obtained. Okay. Another advantage is this smooth operation. It will operate just like a 3-phase induction machine. Okay. Smooth operation is there. Okay. These are the two advantages. Now what about capacitor start and run? This will address this low starting torque problem. Okay. What happens when you are starting out? Both the capacitors will be in parallel, right? And the capacitors will be added. So the capacitance that you will have is a higher value of capacitance. Okay. This is the capacitor, running capacitor. This is the starting capacitor. Now the running capacitor is a smaller one, whereas the start capacitor is large. So what will happen? At starting, high capacitance will give high starting torque. Okay. At normal operation, the starting capacitor is removed so that only this running capacitor is present, so that you will have a smooth operation, right? When there is a capacitor in the auxiliary winding, it will run much more smoothly. Okay, because there will be two magnetic fields that will be produced, main field winding and auxiliary field winding, which will be 90 degrees nearly apart, phase difference both time wise and anyway spatially it is 90 degrees apart. Okay, so this will help in smoother operation. At normal operation, smaller capacitance will give smooth operation. Okay. But there is this disadvantage here that you have to operate the switch. Switch needs to be operated to remove the starting capacitor once it reaches the normal operating speed. Okay, so these are the two differences. There is a minor variation, but these are the various advantages and disadvantages that you can get with these minor variations. So if you draw the characteristics, how it is going to be, both of them if you draw on the same graph. This is the torque, this is the speed. Okay. So now the running capacitor, that means there is only a running capacitor, there is no start capacitor. Okay. So that is going to have a low starting torque, but it will not be 0, and then it will increase, it will reach a peak, and then it will fall. Okay. So this is running capacitors only. Now when you use a starting capacitor as well, then you are going to have a higher starting torque. It is going to start like this, it is going to go like this, and at normal operation, once we remove the switch, then it will follow this path. Okay. So that means this is start plus run capacitor. Both are present. This is the running capacitor only. Okay. Lastly, we have another variation, which is the shaded pole induction machine. So here what is going to happen, if this is the rotor, then the stator poles are going to be salient poles. That means they will be projected like this. Okay. Now these are split like this. Now in one half you are going to have windings. Similarly, on the other side also it is going to be split like this. Okay. Now this, on this again the main field winding will also be present. Okay. So this is the main field winding, and here also you have coils wrapped around one half. Okay. So these are called as the shaded poles, these two. Okay. And this is the main stator winding. Now what is the mechanism that is happening here? Once current is passing through this main field winding, what is going to happen? This core is going to be magnetized, and once it is magnetized, because it is a time varying flux, there will be induced voltage in these windings. These are simply short circuited windings. So the current in the main field winding is going to give rise to a time varying flux. This time varying flux is going to induce a voltage and consequently a current in these windings. Okay. Now these are wound in such a way that it will oppose the flux in this part of the core. Similarly, in this part of the core it is opposing. Okay. So what will happen, there is a slight imbalance between the magnetic field produced because of this and magnetic field produced because of this. This imbalance will help you get a starting torque. Okay, because they are unbalanced forces. Okay. When there is unbalanced forces, the starting torque will not be 0 at starting. Okay. So you can write down current through the main stator winding will give rise to a time varying magnetic flux, and this time varying magnetic flux is going to induce voltage in the short circuited coil, which we call as the shaded coil. Now these shaded coils are wrapped in such a way that they oppose the main field flux. Okay. So there will be an imbalance in magnetic fluxes due to both coils, which will result in a net non-zero starting torque. Okay. But the shaded poles are not very efficient. Okay. These are the least efficient amongst all of the starting techniques that we have discussed till now.